Alrighty, 14.71. We're going back to old Newton. It says that an apple weighs 1 Newton, is hanging on a spring with a spring constant of 1.5 newtons per meter. So let's just go ahead and write this down. We have that our weight is equal to 1 Newton, and we have that our K, or spring constant, is 1.5 newtons per meter. And it bounces in simple harmonic motion, and if you stop the bouncing and let it swing back and forth, the frequency of the simple pendulum is 1/2. So frequency of our pendulum is equal to 1/2 the frequency of the bounce from when it was bouncing before. And we're asked to find what is the unstretched length of the spring. This one took some finagling. So first, we want to mess around with some equations. First, we know from the book that in simple harmonic motion, if we have something bouncing up and down, our spring is oscillating, we have the frequency is equal to 1/2 pi times the square root of our spring constant over mass. And then we also know that, again from the book, that the frequency of a pendulum is equal to 1/2 pi times the square root of gravity over the length of our rod, or in this case the length of our spring. And we know that this right here is actually equal to 1/2 the frequency of our bounce. So what we can do then is just set these equal together and then solve for our length, which is going to be heaps of fun. So let's just go ahead and do that. So we have 1/2 pi times gravity over our length. So now we just go ahead and plug this into right here and then solve it for length. Oh boy, so we have 1/2 pi times k over m all over 2 is equal to 1/2 pi times gravity over length. Alright, and then what we do, again, we just kind of solve this across here. So we have that our M2 L 4 L, and then we have that our length of our unstretched spring is going to be 4 mass times gravity all over our spring constant. So now we need to find what that is. And something to keep in mind here is that this is the length of the spring kind of at any given time, not the unstretched length of the spring. So we just go to the book and find that for a spring, our unstretched natural length is equal to the length at any given time minus the mass times gravity over k. And we already have that our length at any given time is given by 4 of those. So that is just going to be 3 times the mass times gravity over k. So now we can just plug our known values into our little equation here. So that's going to be 3 times 1 times acceleration of gravity divided by our spring constant, and that is going to be 2 meters.